go like that. And this is the pre-assessment, and it says solve each equation by taking the square roots. We're going to isolate the variable being squared, and then we're going to take the square root in order to get rid of the square. So first thing we're going to do is take the square root of both sides, and that leaves us with, we're going to take the square root of p squared. Whenever we take the square root of a variable being squared, we have to introduce a plus or minus outside of the radical. And so the square root and the square will cancel, leaves you with p. Square root of 36 is a perfect square, so you get plus or minus 6. That is your answer, because we can have a positive 6 squared is 36, and we can have a negative 6 squared is a positive 36. Hence why we have to bring in that plus or minus. First, we got to isolate the variable, so we will subtract 6 from both sides. Leaves us with v squared equals 64. We're going to take the square root of both sides. Square root of v squared is v. Plus or minus 64 is a perfect square. That is 8. So my solution is plus or minus 8. We're going to see how sensitive my phone is. If you can hear the knuckle cracking in the back, that is not me. I'm not cracking my knuckles while I'm doing this pre-assessment. Again, we're going to subtract. We're going to isolate. We're going to get rid of things being added and subtracted first. Now we're going to divide by 3. Leaves us with n squared equals 80. And we're going to take the square root of both sides. Square root of n squared equals n. 80 is not a perfect square, so we're going to have to simplify that. We're going to have to break it down. I'm going to break it into a perfect square. I'm always going to look for a factor that is a perfect square. 4 is a perfect square, and 4 goes into 80. So this rad 4 now becomes 2. I still have to simplify the rad 20. I wouldn't want to leave it as 2 rad 20 because rad 20 can also be simplified. So make sure you simplify it completely. That's where many students will make their mistakes. These 2's are on the outside, so it becomes 4 rad 5. So my final answer is, that was a horrible 4, plus or minus 4 rad 5. So make sure that you continue to simplify. Don't leave it as 2 rad 20. That can still be simplified. So that's that one. The next step, so that would be step 1, or the problems that we're going to deal with are isolating the variable and getting rid of the square. Part 2 is going to be completing the square, a different technique in order to isolate the variable. You'll notice that when we solved or isolated for the variable, there was only one term that had a variable. Once we get to expressions or equations with a variable being squared and also to the first degree, we're going to have to choose different methods. Prior to this, we used a times c, but as we found out, a times c doesn't always work. It only works with rational solutions. So many of these problems that we're going to deal with today are irrational. So completing the square. Step 1 of completing the square is move the constant. Move the constant to the right side. So the constant in this case is negative 20. So we're going to have to add 20 to both sides. That leaves me with b squared minus 8b equals 20. Now, step 2 is going to be complete the square. And complete the square means that we're going to take half of our b value. We're going to take our b value, divide it by 2, and square it. So my b value is negative 8 in this case. We're going to take half of it and square. Well, half of negative 8 is negative 4. Squared is 16. So this value if we place it here, would make a binomial square. That's the reason is we're creating a binomial square. This was not a binomial square. That was not a binomial square, so it didn't really benefit us. This is way more beneficial. This is now a binomial square. And we brought this 16. We put this plus 16 on the left side, so we must remember that we have to balance the equation by adding 16 to the other side. This left side, because it is now a binomial square, can be written as a binomial square. It is b minus 4. It's going to be half of my b value, -8, half of -8. And then on the right side, we get 36. Now, we have a variable being squared. So what we're going to do is we're going to get rid of that square by taking the square root of both sides, much like when we had our isolating. So we're going to take the square root of the quantity b minus 4 squared, and we're going to take the square root of 36. The square and the square root cancel, so you're left with b minus 4 equals plus or minus 6. And now we're going to isolate the variable. We're going to add 4 to both sides. And that leaves us with, we'll move that up, b equals 4 plus or minus 6. So we have 4 plus 6 and 4 minus 6. That equals 10. This equals -2. So my solution is -2, 10. A student always asks me in class whether we need to put it in numerical value. And I can understand why they would be confused, because the answer key on these computer-generated sheets do not put them in numerical order. So I remind the students that, yes, you have to put it in numerical order. I don't mind reminding them. That's just part of the job. Step one is move the constant. N squared plus 8n equals 82. We're going to complete the square by taking half of my b value, which is 4, and then squaring it, which is 16. Don't forget to do it to both sides. This now becomes n plus 4 quantity squared, that's half of my b value, equals 98. We're going to take the square root of both sides. This provides us with n plus 4, and we have plus or minus the square root of 98. So we're going to simplify the square root of 98. What am I going to break that into? 4 does not go into that. Not 3. Let's start with 2. Keep it simple. 2 goes into this 89 times. 89, 80, 16. This is a weird one. Oh, not 89. Hello, Mr. Mac. 49. Now that makes sense. This is a perfect square. 7 rad 2. Almost didn't see that. We got to be patient. Sometimes it takes some time to get to the answer. Now we're going to isolate the variable, and that leaves us with n equals -4 plus or minus 7 rad 2. Now, we cannot add those numbers together because they are unlike terms. So my answer is -4 plus or minus 7 rad 2. We've already moved the constant. The constant is already over on the right side, so all we have to do is complete the square. Half of b, which is 2, and squared is 4. This is now a binomial square on the left side. So it becomes quantity x plus 2 quantity squared equals 6. We're going to take the square root. X plus 2 equals plus or minus rad 6. Let's minus the 2 over. And that was fairly easy. And we start seeing how fast and efficient we can be with completing the square. Number 7, we got to move that constant first. K squared minus 5k equals negative 4. This one's more challenging. Take your b value, which is negative 5, and you might want to write it on the side. Take your b value, divide it by 2, and square it. So that's negative 5 over 2 times negative 5 over 2, which is 25 fourths. So we're going to add 25 fourths to both sides. Remember, my binomial square is k minus half of my b value equals, all right, we have negative 4 plus 25 fourths. Negative 4 is equal to negative 16 fourths plus 25 fourths gives us 9 fourths. So we get the quantity k minus 5 halves squared equals 9 fourths. We're going to take the square root of both sides. K minus 5 over 2. Now we have the square root of 9 fourths. We know that when we multiply or divide radicals, we can separate them into their own houses. So we get 3 halves. So this is now going to become plus or minus 3 halves. We will isolate the variable by moving that 5 halves over. K equals 5 halves plus or minus 3 halves. And we're going to separate them into the two problems. 5 halves plus 3 halves, 5 halves minus 3 halves. That gives us 8 halves, or 4. This gives us 2 halves, or 1. 1 comma 4 would be my solution. It's a good one. We are still completing the square. When we complete the square, I forgot one of the parts, and you don't remember it until you get to it. A must be positive 1. Must be 1. So we got to get rid of that 3a. That a is 3 at the moment, so I'm going to divide everything by 3. That'll give me x squared plus 2x minus 24 equals 0. We'll move that 24 over. X squared plus 2x equals 24. We'll complete the square by taking half of my b value and squaring it, which is 1. This now becomes a binomial square. This equals 25. We'll take the square root of both sides. X plus 1 equals plus or minus 5. Let's minus 1 from both sides. X equals negative 1 plus or minus 5. So we have negative 1 plus 5 and negative 1 minus 5, which is 4 and negative 6. You always like it when they work out nicely, huh? All right, quadratic formula. Now we have to use the quadratic formula. Quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And it's when it's isolated for 0, where a is my coefficient of r squared. So my a value in this example is 4. My b value is going to be the coefficient of r. And my c value is going to be the constant. So we have a of 4, b of 5, c of negative 6. And now we're going to take these values and plug it into the quadratic formula. The opposite of b, the opposite of my b value, plus or minus the square root of my b value squared minus 4 times a times c all over 2 times a. Negative 5 plus or minus. So now we're going to do two pieces. We're always going to do the squared value, and we're always going to multiply these 3 values. So the squared value is 25, and negative 4 times negative 6 is going to give me 16 times 6. 16 times 6 is 96. So plus 96 over 8. Let's simplify that. So now we have those two pieces. You're always going to end up with two things being added or subtracted in that radical. So negative 5 plus or minus 25 plus 96 is 121 over 8. We like that. 121 is a perfect square, which is 11. And we get two statements. We get negative 5 plus 11 over 8. And we get negative 5 minus 11 over 8. That's going to give me 6 over 8, or 3/4. This is going to give me negative 16 over 8, or negative 2. So the solution is negative 2, comma, 3/4. Okay. Number 10, we have to set it equal to 0, so we're going to subtract. This is weird because we've been moving everything to the right. Now we're going to move everything to the left and set it equal to 0. So pay attention to that part. That's a little tricky. You get 8 equals 0. Negative 8's right. And my A value is 6. My B value is 8. My C value is negative 8. So the opposite of B, plus or minus square root of B squared minus 4 times A times C, all over 2 times A. Negative 8 plus or minus, let's do the squared value, which is 64. Let's do the multiplication part, which is 24 times 8, which is 192. That's a positive 192 over 12. Let's move this back up here a little bit, create some space. So negative 8 plus or minus 192 plus 64 is 256. 256. 6, 5, 256 over 12. 256. It feels like a perfect square. 2, 5, 6 square root equals not a perfect square. Okay, so we have to simplify. 256. Let's hope Mr. Mac did his math right. I'm going to divide that by 4, and that goes in 64 times. Oh, that was a perfect square. Did I do that right, Mr. I did 253. Hello, 256 square root equals 16. Yes. And that's what we would have gotten. We would have gotten 2 times 8, which is 16. So yes, it is a perfect square. I'm sure you all saw that while I was doing the video, and you said you made a mistake. I did. It's okay. But I caught it because I took my time. And we have two problems, negative 8 plus 16 over 12, negative 8 minus 16 over 12. And that's going to give me 8 over 12, which simplifies to 2/3. This is going to give me negative 6, 12, 24 over 12, which is negative 2. So negative 2, comma, 2/3 are my solutions. Number 11. Set it equal to 0. B squared plus 3b minus 4 equals 0. My A is 1, my B is 3, my C is negative 4. Opposite of B, plus or minus square root of B squared minus 4AC, all over 2A. Negative 3 plus or minus 9 plus 16 over 2. Negative 3 plus or minus square root of 25 over 2, which gives me negative 3 plus or minus 5 over 2. Negative 3 plus 5 over 2. Negative 3 minus 5 over 2. That's 2 over 2, which is 1. This is negative 8 over 2, which is negative 4. Negative 4, comma, 1. last one, I think. 12 problems. Oh, goodness, look at that. Okay, this is a little tricky. I just told you that everything's going to move to the left. Remember, A, when we complete the square, has to be 1. A needs to be positive when we're using the quadratic formula. So I'm going to move that over to the left side because that will provide me with a positive n squared. I'm going to minus the n, and I'm going to minus 7. And all those are lined up, and that gives me 4n squared plus 6n minus 1 equals 0. Pretty sure that's correct. Let's check it. Take a second. Yep, that is good. All right, my A value is 4, my B value is 6, my C value is -1. Opposite of B, plus or minus B squared minus 4 times A times C all over 2A. I do that really fast, and I can do it fast because I wrote those numbers up there, those A equals 4. -6 plus or minus square root of 36 plus 16 over 8. -6 plus or minus, that's going to give us 52 over 8. We're going to have to simplify rad 52, not a perfect square. That one I do know. This is going to be 4 rad 13, and square root of 4 is a perfect square, so we get 2 rad 13. So rad 52 simplifies to 2 rad 13 over 8. Now you can't leave this because all of the coefficients have a common factor of 2. So if we reduce each of those by 2, we get -6 plus or minus 1 rad 13 over 4. The only problem with this is we would never write 1 rad 13. So the proper way to write that is -6 plus or minus rad 13 over 4. The -6 and the 4 cannot be simplified. Mr. Mac. 3, I know everybody in the classroom right now is screaming that I made that mistake. There we go. I think that's better. Okay. And here is the answer key that you can check all those. And as the student said, this answer should be written -2 2/3. He is correct. And this one is wrong. And this one is in the wrong order. And these can be written as plus or minus. So those are little teeny things we've addressed multiple times in class. So that shouldn't be a problem. Good luck. Come and see me if you have questions.